Aloha everyone, it is Ajanette and I am here to demonstrate how to run a correlational analysis in SPSS. I am currently in SPSS and what you're seeing is a data set from a study on college student well-being where we had a number of data points that we collected from participants. We first collected, I'm not going to go in order, but how it's listed here is the demographics first. So we collected demographic data on race and ethnicity, gender identity, age, education level, sexual orientation, political affiliation, and religious affiliation. We then had 6 measured variables that we studied using scales that were created and examined for reliability and validity, and that included college stress levels for college students, self-esteem, social support, happiness levels, self-compassion scores, and stress management self-efficacy. So how confident were they in their ability to manage their stress effectively? Then we collected some lifestyle data, looking at how many hours they slept on average per night, how many minutes they exercised per week on average, what their sleep quality was, the number of days they exercised each week, about how many hours they work in a given week, the number of children they have, the number of pets that they have. And then we collected data on their college status. So this entire sample was a group of college students who were actively taking classes. We collected 2 data points, one where they told us how many units they were taking, and the second where they told us how many courses they were taking. So this is the entire data set. You will be running an analysis to do a correlation, and when we talk about correlation, we're doing specifically Pearson product moment correlation. So that's measuring scale data, and so it's looking at the statistical relationship between 2 data points. And when you enter the data in SPSS, I'm going to start by just doing a demonstration, and I'm going to open a blank screen. And SPSS down here at the bottom has 2 views. It has a data view and a variable view. The variable view is the page where we set up the variables and tell SPSS the names of our data and the type of data that we're going to be working with. And then we have to code the data if appropriate. The data view is where we actually put in the raw scores for those data points. So when we talk about the variable view, I'm just going to do a demonstration for you, but we are going to set up the name of a variable. And so I'll start with a demographic variable, and I'll do race and ethnicity. So there's 4 columns you have to focus on: the name, the label, and the measure. And then depending upon what type of measure it is, then we might have to do something here in the values. So the name column is what SPSS uses behind the scenes to name the variable. Whatever you put in here will become the title for that column of the data view. So in the variable view, every row represents a distinctive variable. Those variables then become a separate column in the data view. In the data view, every row represents a specific participant. So we don't ever have to enter a participant number because it's already assigned to them based on the row in which that participant's data appears. So in the variable view, we start by giving it a name. Now, SPSS is kind of picky. It doesn't allow any spaces or any special characters. So what I do is, notice I capitalized every single word. And then what I do is, once you hit enter, all these other defaults will fill in, and you can rely on the defaults that SPSS uses. Then I take this and I Control C, and I move over to the label and I Control V. Now the label is what appears on your output once you run your analysis. So the more detailed it is, the better. And then you have to tell it what scale of measurement. This is something that is learned in statistics, where you learn that data is nominal, ordinal, interval, or ratio. When it's nominal, it's categorical, but there's no ranks to those categories. If it's ordinal, there are in fact ranks, but the distances between the ranks may not be equal, like first or second place. If it's interval, now it's not only different categories that can be ranked, but the distances between the ranks are equal. For instance, do you have $100 or $200? Now with interval, there's no true zero. So think of like temperature. There's not a true zero. We kind of have a breaking point that we establish, but there's really no such thing as 0 degrees, right? We say below zero, but how it's measured is different. And so a ratio is something with a true zero, like money, where we can now do ratios. We can say you have twice as much money as I have. And when you're talking about Pearson product moment analyses, they have to be done with interval or ratio data. SPSS, notice, only has 3 categories: ordinal, nominal, ordinal, and scale. So nominal is your categorical data, no ranking. Ordinal is your ranked data. And scale includes interval and ratio. SPSS treats them exactly the same. Whether they have a true zero or not, it treats them exactly the same. So for a Pearson product moment analysis, all your variables should be scale data. Now in this case, we're entering a demographic data. Race and ethnicity, it's a category. You're either in one category or the other. So it's what we call nominal data. Most of your demographic data is in fact nominal. And so we have to do what we call code that data. So anytime you're selecting nominal in this third column, now you're required to do a fourth column on this variable page. And that's going to be the values. Over here, when you click on the values column, this little blue button that appears on the right side, you can click on it and it opens a separate window, and now you're going to enter a code. So when we're talking about this particular data set, this is the original data sheet for all the data for that study. And so I'm going to scooch over. The form responses are the raw scores. They've all been cleaned and screened and coded already. And I'm going to scooch over to the demographic information, which is all the way over here in this bright yellow. And down at the bottom, we actually listed the codes for all of the categorical variables or nominal variables. This one right here is age. Age is a scale variable, so it doesn't need coding, but all the other demographics do. So when you do your analyses, you have to start by entering your demographic data. And that's important because you want to run frequency tables and graphs to see if your sample is in fact diverse, consistent with what would be expected from the population. Remember, if your sample is not diverse, then you may not be getting a comprehensive picture of what happens within that population, and therefore your results may not be generalizable. So it undermines the external validity of the study and the generalizability of the study to other data, to other samples. So for the purposes of this demonstration, I'm going to shrink this window, and I'm going to focus here on showing you how to code the data. So race and ethnicity, because it's nominal, we have to come here to the values column and code it. We assigned a 1 to white Caucasian. I'm going to shrink this down too so we can see. And I'm just going to copy this and paste it here. We assigned a 2 to black African American. We assigned a 3 to Pacific Islander. So we put in the number, the label, and add. We assigned a 4 to Asian American. Add. We assigned a 5 to Latinx Hispanic. We assigned a 6 to Middle Eastern. We assigned a 7 to Native American. Add. We assigned an 8 to those who identify as multi-ethnic. And then we assigned a 12 to any other race or ethnic identity that wasn't listed in our choices. And so now we're going to click OK, and the codes appear now. Okay? And then this data has already been coded. So we're going to copy this, and we're going to now go to the data view, and we're going to paste it under race and ethnicity. Now my SPSS actually converts the codes, and it gives it the label that we assigned to it. Now SPSS through the college doesn't do that. So don't get stressed out if your numbers only appear. That's perfectly normal, okay? And you're going to create a variable for each demographic. Again, take the name, copy and paste it into the label, and then add your spaces so it's clear. Tell us what type or scale of measurement. If it's nominal, go back to the values column and code it. So let's do it one more time. This next one is gender identity. I'm going to Control Copy, Control V, add my space. It also is categorical or nominal. So I need to code it over here in the values column. I'm going to scroll to the bottom of the data sheet where my codes have been listed. Transgender person is going to get a 1. Add. People who identify as a man are going to get a 2. People who identify as a woman are going to get a 3. People who identify as gender queer get a 4. People who identify as other non-binary get a 5. and people who identify as any other gender identity not listed get a 12. We click OK, and those are there. I'm going to now collect the data for that variable. Go from the bottom to the top or top to the bottom. Copy, go to the data view, go to the very top, and paste. And there's my data. Now with age, it's not a categorical variable, so I can just type age, and I can say it's a scale variable because it's ratio data. There is a true 0, and I can just copy and paste it. Now I'm doing one column at a time. You can actually enter all your variables and copy and paste all the data at once. That's usually what I do, but since I'm only demonstrating a few variables and not all of them, I'm just doing one variable at a time. Okay, now beyond demographics, so you're going to enter the demographics and code all your categorical data for all the variables. So race and ethnicity, gender, age, level of education, sexual orientation, political affiliation, religious affiliation. It's better if you enter them in SPSS in the same order that they appear in your spreadsheet, because then you can copy and paste all the data all at once in the data view. Now, I'm going to actually demonstrate how to set up the variables that you're analyzing, so your X, Y, and your Z. Let's say that for the purposes of this study, your group chose happiness levels. So I'm going to go to the total Oxford. This is the Oxford happiness questions. And this is all of the total scores are the ones that you use for the purposes of your SPSS analysis. You do not enter the scores for each individual question. You only enter the total scores. We've already reverse scored all of the scores, so they're all ready for you to go. Now, and that's typically what I do with all data. So if we're using another study, look for the highlighted columns and the total scores for your particular scale that's used to measure your variable. In this case, we're going to do Oxford happiness scale. So I'm going to go back to variable view. I'm going to say Oxford happiness, happiness scores. I'm going to Control C, Control V, add my spaces. These are scales. Remember, for a Pearson product moment, I can only do scale variables, okay? So I'm going to go to the top. I'm going to copy all my scores. Once I get to the bottom, I'm going to Control C. I'm going to go to the data view. Here's my Oxford happiness scales. I want to make sure I'm at the very top. I'm going to Control V. So as a double check, the last score should be 19. Here it is, 19. I'm going to do one more as a sample. And let me just go backward. And I'll do social support. Does having a good support system relate to our happiness levels? Let's see. Again, I'm just scrolling down so I can get all my data. I'm at the bottom. I'm going to Control C. Oops, I didn't add my variable yet, so let's do that. Social support. Social support. It's a scale variable. I'm going to go to the data view. I'm going to make sure I'm at my very top box, row number 1, and I'm going to paste. So my top score was a 74, and my bottom score is a 29. We'll just double check. Top score 74, and the bottom score 29. Okay? And so with that, let me demonstrate how to run your analyses. The first thing you want to do is run your demographics. And so how we do that, remember, I only have 3 of the demographics entered in this demonstration. You need to make sure you set up all of the variables from the demographics and enter all of the data. But for the purposes of this demonstration, it's just these 3. So we're going to go Analyze, Descriptives, and we're going to go to Frequencies. You'll remember from stats, frequency tables and frequency graphs are common tools used to represent descriptive data. We're going to focus on the demographic variables. Specifically, we're going to focus first on the categorical demographics. We'll come back to age in just a second. Age is different because it is a scale variable, okay? And we want to do some statistical calculations that are not appropriate for categorical or nominal variables because the numbers entered for these are codes, and those codes don't have any specific quantitative meaning to them. They're arbitrary. And so we don't want SPSS to run any mathematical calculations on those codes. We just wanted to count how many people are in each category. And remember, that's what a frequency graph and table does. It tells us the number of participants reported for each of those categories. So we're going to go to Charts, and we want a bar chart because this is categorical data. A bar chart is used for discontinuous or categorical data because each bar represents a different category. And it's going to automatically give us a frequency table because this little box is checked. We're going to hit OK. I'm also going to now go to Analyze, Descriptives, Frequencies. I'm going to get rid of my categorical. I'm going to add in my age. And I'm going to ask for the mean or the average age. I'm still going to run a frequency table. The appropriate frequency graph is a histogram for a age because it's a continuous variable, and those columns now touch because remember, you may not be 35 exactly. You might be 35 in 6 months, right? So that's why they touch, because they kind of fractionally blend into one another. So we're going to run that. And now what we see is these frequency tables here that tell us of our 283 participants, 89 identified as white Caucasian, 25 identified as Black African American, 3 identified as Pacific Islander, 18 identified as Asian American, 109 identified as Latinx, 12 identified as Middle Eastern, 2 as Native American, 21 as multi-ethnic, and 4 identified as another race or ethnicity not provided in our categories. And so what this tells us is that we had a fairly diverse sample. Now, we had mostly Latinx, Hispanic participants, and that makes sense because MSJC, the majority of our students are Latinx and Hispanic. And while we didn't limit the study just to MSJC students, that is representing the larger population demographics that exist in our surrounding area. And so it is very much very representative and what would be expected given the region in which we live. Now, if we weren't in California, or specifically in Southern California, these breakdowns may look different, right? So we want to say, does our sample represent the diversity that reflects the larger population from which the sample was drawn? And in this case, very much so. We see some gender diversity as well, with the majority identifying as women. That again is consistent, where we see the majority of college students now are women, which has flipped the script, right? Historically, that was not the case, but that is currently the case. We do have a small portion of our sample identifying with gender diverse or expansive identities, and we would expect that because although some people want to deny the existence of individuals with diverse gender identity, the fact of the matter is they exist, they're real, and we want to include their perspectives in our psychological research studies, because we want to make sure our studies are inclusive and representing the diversity of the human experience that is accounted for in our research. And then finally we did age. So our sample ranged in age from 18 to 62, with an average age of 24.4 years. And so you are going to report all of the demographic information. You're going to run the data analysis for every demographic variable we selected. So age, race and ethnicity, gender, sexual orientation, education, religious affiliation, and political affiliation. You're going to run them all, and you're going to use that information to write the participant subsection of your method. You're also going to use this information and collapse it into a demographics table that you will create. And that is also, there's a sample demographics table on page 210 of the APA manual as well. Okay, so beyond demographics, let's actually run your, I'm going to go back to, so you can follow along. I'm going to go back to our sample data, and we're going to analyze. We're actually going to drop down to correlate. We're going to do a bivariate correlation. Notice down here we have our options. It defaults to Pearson product moment, which is what we're doing when we're comparing the relationship between two scale variables. And now we're going to focus on the actual variables, the measured variables that we chose for our hypothesis. And this was looking at the relationship between happiness and social support to see if happiness level is related to the strength of our social support system. We're going to do Pearson product moment two-tailed. We're going to look at options. We're going to ask for the means and standard deviations. We're going to click continue, and we're going to click OK. And now at the bottom of your output, here it's showing you the correlation between those two variables. So you notice you have the correlations, you have the variables listed as both rows and columns. This one right here represents the intersection of the correlation between happiness and happiness. It's the same variable, so it's a perfect one, right? For every score on the happiness, it equaled the score on the happiness. That's a given, okay? Now over here, you're seeing the correlation between Oxford happiness and social support. And it is in fact significant. See over here, when you have 2 asterisks, that means it's significant at an alpha level of 0.01. So there is a significant positive correlation between social support and happiness. R equals 0.506, comma, P equals 0.000. Then you would say, as happiness scores increase, social support scores increase. Or you can say higher social support scores were associated with higher happiness levels, because that's what a positive correlation is. If it's a negative correlation, it goes in the opposite. So we might say stress is negatively correlated with happiness. Higher stress levels are associated with lower happiness scores. And ultimately, you need to do that for all 3 of your relationships. So you would do it a bivariate correlation between X and Y, between X and Z, and between Y and Z. So you should have 3 variables for the purposes of your study. You had 3 research questions, 3 analyses, and 3 results you need to present. These results will be presented in your results section of your paper. Follow the template very closely in the information and outline sheet. Try not to deviate too much because you're kind of early in your statistics career. Some of you haven't even taken Psych 121, so you may not have experience ever running correlation analyses, and some of what I'm even talking about may be unfamiliar to you. And that's okay. Rely on the experience of your lab group members and watch the materials that are provided for you and the guest lecture that's provided for you to expand your understanding of correlations as well. I will also link you to some resources that I use in my statistics class, so you can actually access my correlation lecture that I use in my statistics class, and you can access those videos as well. Otherwise, you will be doing a correlation matrix, and I have brought in a guest lecturer for you that will that does a demonstration video on how to create a demographics table and how to do a correlation matrix. So you are going to be required to do 2 tables, 1 demographics table for all your demographics information, and then 1 correlation matrix. And Joseph Awad is a former MSJC student, a Jack Cook Kent Scholar, and a current student at UCLA and a researcher at UCLA. He is an award-winning student, an incredible model and example for you. And so I'm thankful for him offering his time and expertise and serving as a guest lecturer in the class to help walk you through how to build tables for your paper. So please reach out with any questions. Otherwise, I wish you all a wonderful evening. Thank you so much.